Okay, let's look at some sound intensity and sound intensity level problems. Part A of this question, I'm going to leave you to look through your class notes. Why do we use the decibel scale? Mostly it's because human hearing is just a little bit weird. We don't hear linearly, so we need some sort of logarithmic scale. But anyway, that was kind of discussed in lectures, so you can just review that and make up an answer here. Part B, while walking home one day, physicist Joe encounters his two friends, Bill and Laura. So let's draw our three friends here. Here's Joe. Joe is 2.7 meters from Bill, so let's put Bill over here. R of Bill is 2.70 meters. And then we're 3.5 meters from Laura, so Laura is a little further away. Let's put her down here. R Laura, 3.50 meters. Now, what do we know? Joe measures the sound intensity of Bill's voice as 4.5 times 10 to the minus 5 watts per meter squared. So the intensity from Bill, 4.5 times 10 to the minus 5 watts per meter squared. And the sound intensity level, make sure you tell the difference between intensity and intensity level. So beta from Laura is 79 decibels. Determine, first of all, what is the sound intensity level that Joe measures from Bill's voice? So here we have to use our equation. Sound intensity level, finding it for Bill, is 10 times the log of the sound intensity I divided by IO. So we've got 10 times the log of 4.5 times 10 to the minus 5 watts per meters squared, divided by IO is a constant, 1 times 10 to the minus 12 watts per meter squared, gives us a sound intensity level of 76.5 decibels. Okay, so that's the sound intensity level from Bill. The next part, what is the sound intensity I that Joe measures for Laura's voice? So we're trying to find I this time. To find our sound intensity I, we know that that's IO times 10 to the exponent of beta for Laura divided by 10. So IO is 1 times 10 to the minus 12 watts per meters squared times 10 to the exponent 79.0 divided by 10. Put all that through the calculator, we should get 7.94 times 10 to the minus 5 watts per meters squared. Okay, last, what would be the sound intensity level that Joe would measure if both of the friends were talking at once? Here, the important part to remember is that while you are allowed to add up intensities, you are not allowed to add up intensity levels. And that's because of this log scale. They don't add like that. Okay, so if we want to find the total sound intensity level, we can't just add these two numbers together. We have to do a calculation. So our total sound intensity level is 10 times the log of I total. I total is the intensity for Bill plus the intensity for Laura. Then we've got to divide that by I0. I think I need a new sheet of paper here. So let's put our numbers in here. So that's going to be 10 times the log. In our numerator, we've got the intensity for Bill, that was given, 4.50 times 10 to the minus 5 watts per meter squared. Then we have to add the intensity for Laura. We calculated that, 7.94 times 10 to the minus 5 watts per meters squared. Then we're dividing that by I0. 1 times 10 to the minus 12 watts per meter squared. Putting all that through the calculator, and we get 81 decibels. And you see, that's not simply these two sound intensity levels added together. That would be a very loud sound indeed. That would be well over the pain threshold. Okay, for our next question, let's see what's happening from some explosions. Maybe they're using dynamite to bust apart some rocks or something. So an observer measures the sound a sound intensity level, sometimes it'll just say sound level, of 86.3 decibels at a distance of 2 kilometers from an explosion. So our sound intensity level beta is 86.3 decibels. And this is when we're at a distance r, 2 kilometers away. We need to put that in meters, so 2,000 meters. First part of the question, find the sound intensity of the explosion. So we have the intensity level. Now we're asked to find I, the intensity. So we know that our intensity is IO times 10 beta over 10. 1 times 10 to the minus 12 watts per meters squared times 10 to the exponent of 86.3 divided by 10 gives us 4.27 times 10 to the minus 4 watts per meters squared. Okay, so there's our sound intensity of that explosion. Next part, what's the power of that explosion? So let's remember that intensity is power divided by area. That means that power is intensity times area. When we think about area, we have to figure out what is the area of that sound. It comes out in all directions at once, so that area is the area of a sphere. So we've got I times 4 times pi times r squared. Let's put in our intensity, 4.27 times 10 to the minus 4 watts per meters squared times 4 times pi times our r, that was 2,000 meters. That gives us a power of sound of 21,442 watts. If you're thinking this is a big power, I would definitely agree. This is a very large power. However, this is an incredibly loud sound and we're 2 kilometers away. So it makes sense to me that that power would be really quite large. Okay, third part. What is the sound level, what's beta, if we had 4 bombs and we were 3 kilometers away? So now this is going to take an amount more work. So first of all, let's deal with the distance. So one explosion at 3 kilometers away. Let's find the new intensity. The new intensity is going to be the power divided by the new area. The power doesn't change. So 4 pi r squared, so 21,442 watts, divided by 4 times pi divided by 3,000 meters squared gives us a new intensity of 1.90 times 10 to the minus 4 watts per meters squared. This intensity is smaller than this one, and this makes sense because we're now further away. Okay, so that's for one bomb at 3 kilometers. We don't have 1, we have 4. So if we have 4 at 3 kilometers, the total intensity is 4 of those added up. So 4 times I. 4 times this number, 7.58 times 10 to the minus 4 watts per meters squared. We're seeing now that this sound intensity is bigger than the original. That's because we've got 4 bombs. To find the sound intensity level, we'll have to use our equation. 10 times the log of I total divided by IO. 10 times the log of 7.58 times 10 to the minus 4 watts per meters squared divided by 1 times 10 to the minus 12 watts per meters squared. Put that through the calculator, we get 88.8 decibels. So it does indeed get louder when we have 4 bombs going off, even if we are further away.